Well, hello everyone. It's really great to have you all join us today, and I hope you find this webinar beneficial. My name's Neil Blacklock. I'm a member of the IOSH Hazardous Industries Group Committee, and it's a pleasure to welcome everyone. Today's webinar is on confined spaces, what they are, and the importance of rescue plans. Again, we're delighted to have you all join us as we delve into the critical aspects of workplace safety, and if not controlled sufficiently, can have catastrophic consequences. Confined spaces in a variety of industries, but particularly prevalent in hazardous industries such as manufacturing, gas, utilities, etc. While these spaces may seem innocuous at first glance, they present unique challenges and hazards that demand careful consideration and proactive planning. Before we introduce our speakers, housekeeping. All participants will be muted during the presentation, but there will be a Q&A session at the end, so please feel free to drop any questions in the Q&A box at the bottom. We can hopefully get through them after the presentation, but please be aware there are time constraints and there are a significant number of registrants, so we may not be able to get through them all, but we'll get through as many as we can. If we do have any sort of left over after that, Paul and David from MRS, will get through them and get back to you, and we'll post them out on our LinkedIn. So here with us today, some experts from MRS Training and Rescue based here in the UK. We have a wealth of knowledge and experience in not only delivering confined space training, but also in creating emergency rescue plans and delivering emergency rescue cover. I've worked with MRS on a number of projects on the outage side, on the power generation side, and can personally vouch for their knowledge, experience and expertise. I'd like to thank IOSH for making this webinar possible, and also Andy Morris, who is a member of the HIG group, who was the main driving force in putting this together. But without further ado, let me introduce Paul Ancliffe and Dave Watson from MRS, and let's dive into the world of confined spaces and unravel the importance of rescue plans. Thank you.
Good afternoon, everybody. My name's Paul Ancliffe. I'm the Operations Manager for our MRS Training and Rescue, based in the Birmingham and Widey area. And also I'd like to thank David for presenting the PowerPoint today, and at the end we will have opportunity to answer some of your questions. I'll hand over to David.
Right, good afternoon everybody. Like Paul said, my name's Dave Watson. I've been with MRS for about 5-6 years now, so and obviously today we're going to talk a little bit about confined spaces. So without further ado, obviously I will get on and we'll have a look. So first of all, we're going to look at why we're doing what we're doing, in the fact that we'll look at a little bit of what the legislation says, and then we'll start looking a little bit more detail as to what the actual confined spaces regulations say with regards to what we should and shouldn't be doing. So I'm sure most of you are aware, obviously in the UK we have the Health and Safety at Work Act 1974, which places duties on the employer with regards to its employers. So under section 2, it says that obviously we should provide a safe place of work, safe access to that place, safe systems of work to make sure that we're working nice and safe, and provide any kind of training, information and supervision that we might require for whilst we're doing the work that we're doing. With regards to the regulations, so UK regulations, specifically around the Management of Health and Safety at Work Act, talks about that in Regulation 3 that an employer must carry out a suitable and sufficient assessment of all the risks with regards to work activities and decide what measures are necessary. Okay, so so that's just basically something along the lines of as to why we have to do it. When we look at specifically about the confined space regulations, the confined space regulations 1997 define a confined space as any place, including any chamber, tank, vat, pit, silo, trench, flue, well, or similar space by virtue of its enclosed nature, there arises a reasonable, foreseeable, specified risks. In general, so the general overview of the whole of the confined space regulation says wherever possible, we should try and avoid entry. So, and technology and things like that are kind of now developing such that we're trying to develop these areas so they can completely be autonomous. So we don't need to go in. So things like using drones, cameras, yeah, even the responsibility of obviously manufacturers to kind of design out these kind of issues with regards to what a confined space is. It also goes on to say that if we can't avoid it and we need to go in, then we're going to have to do things like a risk assessment, which will then obviously develop into the control measures. And then there's something that we tend to use, which is called a safe system of work, which is where you've got all your work instructions, you've got all your risk assessments, permits, all that kind of stuff. And then the big one really from that perspective is the fact that, you know, you should have and you should have made plans for any kind of emergency that may arise from someone having entered into that confined space. When he talks about the specified risks, there are generally, so the first one really is to do with injuries to people from a risk of fire or explosion. The next one talks about the loss of consciousness through an increase in body temperature. You might note that it says increase in body temperature. It doesn't mean a change in temperature. Okay, so it kind of looks at the fact that if we talk about the cold, then obviously you could actually put layers on to prevent yourself from becoming cold. Whereas with regards to the body temperature, once you've kind of got down to kind of skin level, you can't go any further. So it's being aware that obviously that through that increase in body temperature. The next one is obviously looking at the consciousness of asphyxiation from arising of a gas, fume, a vapor, or the lack of oxygen. Oxygen is quite a weak gas with regards to other gases, okay, and it is very, very easily displaced. So we kind of need to make allowances for that sort of stuff. The next one is obviously the drowning of a person arising from the level of a liquid. So things like working in reservoirs and things like that. So you've got flash floods, all that, full failure of isolations, which is another one. And then finally, the asphyxiation of a person arising from a free-flowing solid or the inability to reach a respirable atmosphere through entrapment. So things like working with grain, flour, you know, in silos or bunkers or something like that. Little note at the bottom there, which basically says that obviously these hazards could just be naturally present, yeah, or it could be being introduced by the work that you are doing within that confined space area. So they're what's called the specified risks. So in order, like it says, for an area to be categorized as a confined space, you have to have, as I say, that restricted area plus one of those specified risks needs to be present. If you do have a confined space, then obviously somebody needs to obviously define what it is. A competent person needs to be appointed to obviously manage that area. Things like identifying what the specified risks are, and then obviously risk assessing that and trying to eliminate them wherever you can possibly do that. Obviously, then the next part is obviously looking at trying to devise a safe system of work, including thinking things like isolation, ventilation, whether you need any access equipment, what kind of lighting is required, all that kind of stuff. And then you need to thinking about the people that are going to be entering it. So what competencies do they have? What training have they had? Yeah, are they fit to undertake the work within the confined space? And finally, obviously, again, talking specifically about things like rescue arrangements, including what rescue equipment is required as well, all right, which will all need to be defined prior to anybody entering into a confined space. There are a couple of handy little kind of guidance notes and approved codes of practice issued by the Health and Safety Executive. So INDG 258 is, again, these are kind of accessible via the HSE website. And it gives you some guidance with regards to what you should and should be thinking about with regards to working in a confined space. The L101, the approved code of practice, kind of sits hand in hand with obviously the confined space regulations, and it kind of explains it in a little bit more detail as to what you should be considering when it comes to, again, safe working in a confined space. When we talk about confined spaces, we generally classify them in one of two of the classifications. Now, there's a Water UK standard classification, which calls them NCs, which is specific to do with the water industry. And then there's what's called the National Occupational Standards, the NOS, which are kind of like what we call job profiles with regards to working in confined spaces. So if we look at the first one, the Water UK, they tend to be, well, they define them as NC1, NC2, NC3, NC4, and NCX. NC1 is a kind of low risk, shallow entry, such as things as meter pits, valve chambers, and things like that, where ventilation is quite good. It's simple, it's unobstructed access to or egress into that sort of place. So something which is kind of really, really easy to kind of get in and out of. The next one is obviously NC2, where it's probably getting a little bit deeper. So it's vertical, it's direct, it's unobstructed, and you're continuously attached to a person riding hoist or a similar mechanical rescue device. It's such that if there is an emergency, then the person acting on the outside can then simply engage the winch or the hoist and then pull you out of, or pull the person out of the confined space. NC3, again, is vertical, direct, but this is where it is not possible to be attached to a safety or a rescue line. And it would generally involve people moving away from the point of entry. And these ones are normally where we get like a team entry. All right, so there's a team of people that kind of go in and do that kind of stuff. The NC4 is where it starts becoming a little bit more complex. So it might be a non-standard access or egress. It might require specific controls, and it might require a specific type of rescue arrangement in order to get someone out of that confined space. And then quite recently, or I say quite recently, they introduced NCX, recognizing the fact that not all confined spaces are, vertical entries. Some are horizontal, some of them you access by going in and then going up. Yeah. And you may have to have specific kind of atmospheric condition, analysis. Certainly access arrangements may be a little bit different. And certainly the rescue plans would have to be devised specifically for risks which are going to be in that area. So that's the NC, that's the Water UK classifications. The National Occupational Standards talk about very, very similar in some ways to the Water UK. So the low risk entry is simple, unobstructed, good natural mechanical ventilation, low likelihood of a reasonable foreseeable risk being present, and it may involve working alone or as part of a team. So something, again, along the lines of the valve chambers, meter pits, or something like that, okay? The next one is obviously the medium, and obviously that's a bit of a deeper area. Entrance may not be in sight of an entry point. The standard entry or egress will inevitably involve maybe some access equipment. The specified risks, whilst being identified, are easily controlled. So through either isolations or something along those kind of lines. Medium risk would generally involve a team entry. And it's based really around the fact that all the people going into a medium risk will carry an appropriate escape breathing apparatus, depending upon things like, how far they're going into the confined space, what they're doing in the confined space, and there are a multitude of different types of escape breathing apparatus currently on the market for that kind of thing. And then finally, and I'm sure most of you kind of worked out what the third one is, it's kind of a high risk kind of confined space area. It's generally non-standard. It could involve like a remote entry to a specific area. There will be specified risks, and they may not be able to be easily controlled, or the work activities that you're doing inside the confined space may increase the risk level, so that you need to be thinking about wearing breathing apparatus when you're working in those kind of areas. All of those kind of areas that we're talking about will require some element of people being outside of this confined space. So whether you've got people like entry controllers, you're certainly going to need someone in charge of the works, you're going to need a supervisor, and then as it says, it's at the end, you're going to need like a fully equipped emergency rescue team to enter without delay whilst the confined space is live. Okay, so they're the classifications generally for what our confined spaces are. When we start looking at specifically hazards around confined spaces, so not specific to those specified risks, but there are other things that could cause an area to become difficult to get in and out of. So things like, whether there's chemicals involved that you're working with, whether there's mechanical equipment, falling from heights. So inevitably, if you're going a vertical entry, there is a potential for falling from height, contact with moving machinery. There's biological hazards that we need to think about. So if you're going a lot of places, if you work in plants and machinery, then there is always the danger of things like Weil's disease or leptospirosis, should we say, hepatitis, obviously tetanus, are all kind of biological hazards that we kind of need to think of. A lot of obstructions, so obstructions within the area, certainly with regards to maybe probably height restrictions. And then you've got human hazards. So people tripping, stumbling over things, or even to the fact that there are too many people within the confined space. I've been on a few jobs where we are providing rescue for, and we've come across hazards that wouldn't have normally presented themselves to us. The image that you're seeing on the right-hand side there, that was a job that we were doing up in Edinburgh. It was quite benign, or so we thought. We were laying sewage pipes into a field. It was going to be a new housing development. So we were laying in the sewage pipes, with the manhole cover, manholes and all that kind of stuff. One particular day we came in, again, part of our remit was that we would test the environment prior to anybody going into the area, which we did. And as I was testing the area, as I put the monitor in to test it, the monitor immediately went off. I was a bit concerned. I thought I might just have a faulty monitor. So we changed the monitor, tried a different one, and it was doing the same thing. When we finally tested the bottom of the trench that we were putting these pipes in, the oxygen level at the bottom of the trench was 6%. So 6% is a sort of level of oxygen that you have a very, very limited amount of time. You probably, within 30 seconds, probably less than a minute, you're talking about the fact that you will be, you'll be dead. Not kind of just feeling a bit unwell, you'll be dead. Because if we all know, no oxygen means we're kind of going to die. All right. So we were quite concerned. Obviously, after the incident, it was like, why is this happening? Where's it coming from? And it was literally leaching out of the ground. There was high levels of carbon dioxide in that trench area. And as I say, unbeknown to us, had the contractors arrived before us that day and just jumped in the hole because they were doing something, we could have been pulling bodies out of the confined space, which is, again, never that good. There is a little bit of a flowchart that you can sort of look at here with regards to deciding whether something is or isn't a confined space. It simply flows that, is it substantially or totally enclosed? If it isn't, then it doesn't conform to the confined space regulations do not need to apply. If you have one of the specified risks, then it is a confined space. If the answer is no, you don't have one of those specified risks, does the work involved that you're doing introduce one of those risks, in which case then it is a confined space. So sometimes, majority of the time, most people just kind of call it a confined space and then just kind of put all the measures in place that need to. So the next little bit is looking at things like how we would prepare to enter and exit a confined space. Not to kind of train or teach you in any kind of way, but this is just some of the considerations that you kind of need to think about whilst and if you are preparing to enter or to work inside a confined space. So a lot of the time, certainly working in confined spaces, we always kind of get people to think about the brief, think about who's going in there, think about who's doing what. Think about things like a point of work risk assessment. So again, a lot of risk assessments are written well in advance of going into a work area. But again, on the day, something may change, the weather for whatever reason. And rather than stopping the job, obviously providing a point of work or a dynamic assessment allows the work to continue as long as it doesn't affect the main body of that assessment. Making sure that everybody's aware of what their roles are and things like that, making sure the equipment's appropriate, making sure we have what the emergency arrangements are, making sure that everybody's aware of what they are. Things like communication equipment. Certainly if you're moving away from a point of entry, you'll certainly need equipment to be able to talk to people inside the space and in some ways to contact your site agent or whoever's running the area. Making sure isolations are all confirmed and they're in place, and making sure that in the majority of instances that a permit is in place in order to carry out the work. So once we've done all the briefing, then obviously making sure that things like we've got a suitable and appropriate exclusion zone, and we've either got barriers around that. We've got warning notices clearly displayed saying to people that we're working inside the confined space. Vehicle movements in the area are reduced. Someone is monitoring the weather conditions. So if the weather conditions suddenly change, it will start to affect the environmental conditions inside the confined space. Yeah, making sure that entry and exit equipment's are properly checked as well prior to anybody going in, and that you have a safe means of access and egress, and there's not a lot of equipment kind of scattered around the entry point, which would then make it very, very difficult to get into and out of. We have to consider the environment inside. So it might be that you kind of need ventilation systems. Ventilation systems, we either have, there's a natural ventilation, or there's forced, or there's instruction ventilation. And these generally are there to make sure that the oxygen content doesn't fall below 90%. It kind of dilutes in any kind of gases or any flammables to prevent that kind of build up. Extracts dust, or dilutes dust. And in some ways it controls the temperature and humidity whilst you're working inside that confined space. A lot of times, what a lot of companies tend to do are a lot of combined ventilation systems. So you'll find that there may be an area where they're forcing the air in, and then somewhere else further inside the system, they'll be extracting it out. So a lot of waste recycling centers, when we do a lot of work in those kind of areas, they have a lot of air being sucked in or sucked out from one area, and it's being drawn in from another area. So there's huge fans and huge kind of ducting areas where this kind of process happens. And it generally does work to keep, certainly controlling temperature and things like that. The next one is obviously a consideration for things like gases. Okay, so the gases we monitor inside a confined space, it's quite critical that we make sure that, A, they don't so kind of creep up on you and build up to a level that it's going to cause you any problem. Or, so those gases can either be asphyxiants, they can be flammable, they can be toxic, or they could be explosive. They could even be a combination of, one or all of them. Okay, so you just have to be aware of what these gases are and how they work. So in order to have these gases, then what we have are monitoring equipment. So again, generally, it's either going to be a fixed monitor. So some areas that we've been to and some jobs that we work on, they have fixed monitors. So the area is constantly being monitored all the time. Or generally what people have are battery powered monitors, which people either wear them or they're fixed inside the area that people are working in. And that's just a kind of an example of some of the different types of gas monitoring. But it's always a good idea to have gas monitors because it's doing something that you kind of need to be aware of, and it's doing it in the background sort of thing. What we're monitoring for are obviously, this is just as an example of some of the gases that are likely to be found. Generally, the gases in this table are in what they call specific gravity order. It's also good to know what kind of specific gravity of these gases are, so you at least know where to look for them. So if you look at the top, you'll see hydrogen and methane are very light gases. Okay, so they'll tend to sit at the top of a structure. Whereas sulfur dioxide, nitrogen dioxide are really heavy gases and they'll tend to hold around the floor. There are what they call work exposure limits. So if you look at the guidance on the right-hand side, all of these guidance, times and exposure limits are all contained in what's called the EH40, which is the Workplace Exposure Limits document. And again, that's produced by the Health and Safety Executive. But this is where these kind of limits come from. So a work exposure limit is worked based around what's called a time-weighted average over 8-hour period. So if you take a typical kind of gas there, say it's carbon monoxide, you'll see that it's kind of attached itself around the breathing zone. It has a lower limit or a work exposure limit of up to 20 parts per million. Whereas it also has what's called a short-term exposure limit. So if the level increases to beyond 100, you've got less than kind of 15 minutes to be in that area. Okay, so it's kind of one of those things that, again, the reason we monitor it is because we're wanting to know how much we're being exposed to and, whether we're getting to sort of areas where the gases are too dangerous for us to continue. So once the confined space has all kind of been done and all the work is finished, obviously then we have to go through and we have to make the area safe. So the reasons we do that, again, is quite obvious in the fact that we don't want people going in after we've come out. Okay, it's to obviously stop things from going in, debris, waste, or whatever. It allows a natural kind of closing off of the permit. So the last thing you do is making sure that everything is out. We close the top and then the permit is signed off to say we've sealed it and it is now back to how we started. Obviously, as I say, this is just a little bit more on that. So it talks about site protection. It removes the risk to the public. Not all confined spaces are on sites where we have clear control over, people getting access to and egress from those kind of places. It could be that you're working at the side of the road or something along those kind of lines. So again, by sealing it up and closing it down, you are preventing any people or the public from getting access. And again, it is a legal obligation. It does say in the confined space regs that a confined space has to be sealed up when you've finished working inside it. All right. So next bit is really talking about like the typical equipment that we're likely to come across whilst you work. As I say, this is just some of the typical equipment. So things like tripod or a side entry system. So quite a lot of tanks and silos. You can get what's called a side entry system now, which does make it easier to get into and out of. Rescue retrieval devices, fall arrest, full body harnesses, you know, and to some extent making sure that they comply with, you know, they have a rescue attachment to them as well, which would help getting anybody out of a vertical kind of confined space. Connectors, rope, gas monitoring equipment, respiratory protective equipment. So whether that is escape breathing apparatus or whether for going into, say, a high risk area, you know, you have to wear, you know, open circuit breathing apparatus, or even to the fact of closed circuit breathing apparatus. Depends very much upon the area that you're working in, and, you know, communication equipment. So things like two-way radios or and things like that. So limitations with regards to what equipment you're going to use and how you're going to use it. It could be due to its size. It could be down to the fact that, you know, it's not, you know, you've got a limited time duration working with stuff. So, you know, certain RPE will only kind of last for certain set periods of time, or even things like radios having things like batteries and stuff like that. Other things that likely you come across, things like, you know, people misusing equipment, people not being trained or competent to be able to use it, entanglement from things like, you know, hoses and stuff like that, contaminating breathing apparatus from, you know, chemicals and things like that. And then we talk about personal factors. So a lot of equipment that we use, certainly within the confined space world, is weight dependent. So it's got a lot of weight limits and things like that. So specifically around, you know, access equipment. And again, we talk about respiratory protective equipment, the impact of facial hair. And the fact is that people have to be face fitted for that kind of equipment. All right, so there's some of the factors that could affect using that equipment inside a confined space. And then lastly, I could talk to you a little bit about emergency situations and the reasons why we do things, okay? So some typical hazards that likely could occur within your confined space. And if you look at the top sort of 4 or 5 or 6 of those, you'll see that they are specified risks which could happen. All right. So despite your best intentions of putting all sorts of control measures in place, you know, an isolation could fail. For whatever reason, a gas is built up to the fact that it's now causing, you know, a fire or an explosion risk. Yeah. Or it could simply be the fact that you're working in a confined space and the weather has changed, the sun comes out, it heats up that nice big metal silo, in which case inside that area, the temperature becomes such that people start getting, you know, hot and stuff like that. Other hazards that you're likely, things like power failure. If you've got a ventilation system that's operating and it's keeping that flow of air inside, if suddenly you lose your ventilation system, then it's an emergency and people need to be withdrawn from outside the space. But a lot of the time, hopefully, if you've put all your control measures in place, you've got everything in place, then the chances are the only things you're likely to come across are maybe, you know, an injury or an illness from someone either tripping over something or generally not feeling very well prior to them going in which case their illness becomes exacerbated inside. So the idea is that we need to minimize the risk of putting these arrangements into operation. So wherever possible, you're thinking about putting a team together to be able to go in and get someone out. it says there statistically, if there's a confined space incident that happens, and we're talking about multiple casualties inside that confined space, you can pretty much work out that the second person that was in there that suddenly, come into difficulty was probably one of your first would-be rescuers. And it is statistically, the entry controller who sits outside or stands outside, suddenly, his mate who's working inside the confined space suddenly becomes, a little bit unwell. He shouts inside the space to acknowledge that he's still okay. He gets no response. He thinks his mate has gone down and collapsed. It's natural human instinct to think, I can get into that confined space and I can make a difference. The problem you've got is that if they've succumbed to something inside that area which has potentially killed them, it will affect the first or the second person or the entry controller. His ego's in, and there has been incidents of this, throughout the last kind of 20 years. So it kind of certainly, if I refer to so an incident that happened in 2004. That happened over kind of Thetford, where 3 people lost their life, and one was, had to be taken away for, through serious injury, through serious kind of medical problems. But effectively, a guy was working on top of a slurry tanker, or a slurry tank, should I say, a holding tank. And the guy kind of got up on the top because he was trying to unblock the outlet. So he jumps up on the top with a hose and tries to, aim the jet down at the bottom. He slips for whatever reason and falls in. The guy operating the tank, obviously his friend, his mate, sees him fall in, panics, jumps up on the top of there, and then jumps in to try and rescue him. Again, he doesn't appear, so a third person jumps up on the top to try and rescue him. He looks inside, he sees one face down, one face up. So he jumps in thinking he can make a difference. Again, he doesn't come out either. And then the fourth person, fortunately, luckily, recognized that he was feeling a little bit unwell. He got out, but that was 3 people dead in a slurry tank for no apparent reason. So, 2 people died needlessly because of the fact that they thought they could make a difference. And you kind of think from an industry, we would learn lessons from that. And you kind of say to yourself, it'll never happen again. Unfortunately, it did, and it does. Quite recently, 2016, again, a guy, a young lad, 19-year-old apprentice working over kind of Leicestershire way, was asked to go into a tanker, so a road tanker, to clean it out. So the tanker held like a semi-liquid pig feed. So he was asked by his supervisor to go in to clean the tanker out. So he puts all his waterproofs on, takes his hose in, takes all that, goes in to clean it out. For whatever reason, becomes, overcome by fumes, likely, and obviously collapsed inside. His supervisor obviously heard a collapse, looked inside the back, saw this young apprentice kind of lying on the floor inside the tanker. And again, it's that natural human instinct. He kind of jumps in to kind of try and rescue him. Again, the situation was that, he lost his life as well. So that was, again, 2 people died in the back of a tanker through, an increase of a gas. So, these things happen. And again, I keep referring to that, it's very easy to say, it's very difficult to do. If you're standing there, and your friend is inside, and you kind of, it's just natural, all right. But the idea is to stop. The one after that, it talks about resuscitation equipment, and then obviously being able to put into operation your emergency arrangements immediately. There is a little bit of caveat there on the bottom of that. It says you can't rely on the public emergency services. That's not to say that the public emergency services aren't good enough to rescue somebody. It's just that if you think about even current pressures that are on these agencies, even today, if someone's inside a space and you need something like an ambulance or something like that, you could be waiting hours for help. Again, fire service, if the fire service has to travel some distance, they've got to get to you. They've got to get in, they've got to then build a plan, and they've got to get in there to get the person out. If you're talking about a reduction in gases, you haven't got time. You've probably got less than 30 seconds, even less than a minute. So that's why we always say, if it's a potentially high risk or a potential, it's a medium risk area, that your emergency team are immediately on standby, ready to go. And I don't mean the kit is in a box and it's all nicely packaged. It's literally on the person, ready to go, should they need to get called in straight away, because that's kind of what you need. So a rescue plan should have things like, so it should define what kind of rescue resuscitation equipment you've got or you need. It should say how you're going to raise the alarm and what the method of rescue is. How are we going to safeguard the rescuers? Do we need to consider things like fire safety? Control of plants. So a lot of areas may be quite remote. So you may be using things like generators, pumps, and things like that. If suddenly that generator, that pump fails, then you're also now endangering the lives of the rescuers. So, it's important that that plant is kept running for whatever reason. First aid. So most rescue plans will have to define what kind of first aid, and equipment that you're going to need. And if you need to call the public emergency services. If you do, how do you call them? And again, from the rescue plan perspective, training, having trained operatives who are able to kind of do that kind of thing, and be able to go in and rescue someone out of a confined space is absolutely important. Once obviously you've built your plan and you've got your plan and everything kind of, you're quite happy with it, then have it tested. And again, it's very easy to put something down on a piece of paper and to write it out. But again, it's quite important to kind of test that plan. And again, we're currently working with a company in Birmingham doing quite a major project on the A38. And when we first started with the company, we gave the rescue plan. We built a rescue plan around what we saw and what we could do. We then asked if we could test it to see whether it would work. And then currently when we tested that plan, we realized that we had a few, not failings, but it was a few areas that we had concerns over. And when we looked at it, we then went, well, there is a bit of equipment that we could use which would better suit this type of rescue. So we changed our rescue plan to fit the situation. So we've evolved a rescue plan around what we do with that company. And the company are quite happy with that. And they allow us the time to actually go and practice this kind of rescue stuff, which is very, very good. And I believe that's where I've finished. So finally, are there any questions? I'll hand it back over to Neil.
Thanks, David. Thanks for that. A fantastic presentation. I think you got a lot of information in there in a very short time, so really appreciate that. In the Q&A, we do have a few questions, so I'll just work through them sort of chronologically as they came in, really. So first one is, regarding rescue plans for fairly simple short tasks in a confined space, If one operative is in the confined space and 2 operatives outside, what level of information would you state is required for the rescue plan? The operative could still require rescue.
So again, from a rescue plan perspective, I mean, you kind of need to know, what are the risks? If it's, again, dependent upon the type of confined space it is. If it's a low risk, it might just be a go in and grab and get out. If it's medium risk, it might involve going through a small aperture or something like that. That's a different thing altogether. If something happens to the person inside the space, whilst it might be easy to withdraw them and just grab them and bring them out, again, one of the reasons why we get people to wear full body harnesses, it's not because they're going to be in a fall arrest situation in sometimes, but it's easier for a rescue person to rescue somebody by grabbing harnesses and then dragging them out. Is the space large enough to accommodate a stretcher? If the person has become incapacitated, then you're going to need to think about the type of stretcher which goes into the confined space. Like again, the rescue cover job that we're doing in Birmingham, we've had to develop different types of rescue stretcher specifically for rescuing out of specific different areas, because there's not always one stretcher fits all applications, because it doesn't work. But the people on the outside still need to be trained in kind of rescue and recovery of that person. There are specific things that they need to know and be aware of. Again, even to the point of saying, I'm not going to go in there because I'm endangering my own life.
Yeah, so it's all risk-based, really, isn't it?
Absolutely.
Just move on to the next one. So, is there a specific length/distance of tunnel defined, which then determines that is a confined space?
No, not really. It's just the work. It's just the area and the likelihood. We work in some very, very long tunnels, for example. We work in a lot of very, very deep, deep mines, for example, who've got some very, very long tunnels. So it can be, quite short, quite long. It doesn't really matter.
Okay. Next one then. So it states increase in water. Our coolant towers have water presence. This does not increase. Would it still have the potential to be a confined space?
If there's water likely to come into the area you're working in, yes.
Next one. So is 19% oxygen level acceptable given the normal 21%?
Again, you're kind of monitoring the area using a gas monitor. So, and again, I think I emphasize the fact that, going into these areas, it's always good practice to take a gas monitor with you. That will alert you at 19.5. Okay, so, or predominant hours alert us at 19.5. So we're well aware way before then anyway. Remember, a ventilation system can't increase the amount of oxygen within an area, but it will help to maintain it at a level above the 19% kind of threshold.
Yeah. So I think just to clarify that it's a cut-off threshold, isn't it? Because as I say, when
you're
in confined space, alarms can be set at 19.5. They can even be set higher, can't they? I know some.
They can, yeah. Again, it's down to individual kind of operatives. Sorry, not the operatives, but the companies where these things are worked or used.
Okay. Next one. So for trenches, is the guidance on the depth of them that make them potentially confined space? So air sampling would need to be checked?
No. If again, I did a little bit of we were made aware of something which happened. So there was an incident that happened at Kettering Hospital quite recently, in fact, 2022, where someone was found unconscious with their head in a manhole cover. He'd lifted the manhole cover up. He was unblocking something or one of the pipes. So he was simply, obviously, down on his knees. He was leaning into the manhole, and he fell in, and it was only because he was overcome by a gas which was inside the manhole. But again, trench wise, The trenches I referred to on the job that we were doing in Edinburgh, they were 4 meters, but equally, it can be a meter deep. If you're putting your head in an area or working in an area where potentially you're going to be, bending down, stooping down into it, whatever gases are in there, you're going to be succumbed to because it's going to go into your breathing zone. So you kind of know, you need to know. So.
That's great. And obviously that refers back to your previous slide when you talk about the gases, etc., in the different areas, zones, breathing zones.
Yeah, definitely.
So the next one, so I think this goes back to the 19% oxygen level question. So also that not allowing anyone into a confined space following exiting for a break, for example, as they may have an issue with no support. This happened when I was on Sellafield. Operative return and was overcome by argon gas. This was being purged prior to welding pipes. So I don't know, it's not really a question, but obviously that's an example of.
Yeah, absolutely.
Why not to go back?
Yeah. And for every example that I've used, there are a multitude of ones which, again, we in some ways we kind of, if we get away with it, we get away with it, and people don't tend to talk about it. I think sometimes in industry, I think if we were just to talk about those kind of near misses, I think people would be more or better informed. So people are then more aware. Confined spaces are one of these things that we only tend to hear of the really, really bad sides where people have died. I think if we got to that stage where we were reporting things where we had a near miss, I think a lot of people would learn an awful lot more lessons with regards to confined spaces.
No, definitely. I think it goes. You made a great point about entry controllers and that before about the importance of them, and then again would be rescuers having to trying to jump in and trying to help out the human nature. To again, if we can give examples of the near misses surrounding them, just help inform people.
I mean, we always emphasise, and we try. We emphasise it quite a lot. Certainly when we're training people up to be an entry controller, at no point do you go in. You don't go in. You don't go in. You don't go in. And we kind of re-emphasise, even to the point where we get the guys in there and we go, "Is it all right if I nip off and go and get a cup of tea whilst you're in there? Because I can see the hole." And it's like, no. We tell them, no. You're there. You have a job to do. It's very important. It's probably it's one of the most important jobs. That entry controller is the person who is controlling everything, both inside and outside that space. So he's got a very important job to do.
Yeah. Just moving on again. So, would you recommend using a contractor train for confined space work rather than staff?
Absolutely, because that keeps me in a job. but equally, I mean, we train and we work quite closely with industry. We work quite closely with teams. We like I say, we'll train the team. We will help them put their plans together. We will then even go to the point where we will help test their plan. Yeah, that's what I mean. So it's not just we'll train you, we'll let you go off and work it out yourself. It's the full package where we'll help. I would feel I think I'd failed if I trained a team and they went away and something happened and I go, maybe if I'd emphasize that a little bit more.
No, definitely. I mean, again, it comes down to competence, isn't it? So just training's not enough. You need the experience, and companies like yourself have.
And it takes a certain type of person. It's not, it's not for everybody. Not everybody will want to do, the rescue and recovery of inside a confined space. Some people just won't want to do that. I get because you're putting yourself, if you think about it, you're putting yourself in harm's way. Certainly if you've got a release of a gas in a medium risk area, and your team have put all their breathing apparatus on, and then it's one of those, we're going into danger, we're not moving away from danger, but we're going in to try and make a difference and try and rescue somebody should we have to. So
okay. The one, would it be possible to share where the statistic for one would be rescued killed for every 2 worker can be found? Important learning I would like to use during training in my workplace.
Yeah, absolutely. Yeah.
Great, yeah. So we can get that and we'll put that out.
Yep.
Next bit. So, in the event of an emergency team being deployed in a BA breathing apparatus due to an atmospheric hazard, i.e., slurry tank, there's likely that the H2S, I can't remember which one that is.
It's not a train.
H2S, low O2 and CH4. The breathing apparatus will protect the team against H2S and low O2, however, not CH4. How do you tell the team to ignore a particular alarm but not another?
Again, I mean, from a particular job that we've done in the past, we've actually disabled some of the alarm functions, because the last thing you want is, when you're going into an area with breathing apparatus on, is this alarm to constantly keep going off, because it's just a distraction. You're already in breathing apparatus. You're already kind of pretty much well protected. And again, it might be that we carry ventilation stuff. So if we have to, we can put our own ventilation systems in there to get it. Plus we have other apparatus that we have access to. There's a lot of the closed circuit breathing apparatus, for long duration stuff as well.
I just had a bit there, David, about the CH4. He says, however, not CH4. Even though CH4 can be explosive, once it reaches the explosive limit of 5% or above, large quantities of methane can also displace oxygen, which therefore would cause oxygen deficiency as well. So technically, the BA would protect you from CH4.
Yeah, but I'd say only the sort of asphyxiation risk rather than
yeah. Because obviously, the higher risk is obviously the explosive risk, but technically you wouldn't be in there at that, but you could be in there on higher levels. If it's exceeded the explosive limit, it then becomes an asphyxiant hazard.
But again, from a rescue, from a team leader and from someone who would be managing a team, if levels were such that I didn't think that I could control them and my team were being compromised, I wouldn't allow them to go in anyway. We would simply hold off and come up with a different plan.
Yeah.
It's great. Really great to hear the Q&A. There's a lot of questions. They're still rolling in now, but we are running out of time, so probably only have time for 1 or 2 more, but we'll take all the questions and hopefully David and Paul will be able to answer them. We can put it out later.
Yeah, absolutely.
So this one, there are risks associated with gas monitors, such as testing and calibration to ensure the effectiveness of gas monitors. Sensor testing / bump testing are often ignored. Is this something that you have had experience or that is commonly reported in your experience as confined space specialist?
I seem to have lost a little bit of that, but
yeah, I think the answer, it is good practice to obviously bump test. Calibration's a requirement mostly on a 6-monthly, 180-day cyclic period. But, it's good practice to bump test them every 24 hours. And this ensures effective operation of the machine once it's in the confined space, and will identify any anomalies, obviously, prior to use. So, it is in good practice to do that.
Yeah. So probably have to make this the last question now. So, what competency does a rescue person need? Could a medium risk person use a stretcher? Could one person be trained to manage a rescue or manage the team?
On the medium risk side, use a stretcher. Yes, if they've received relevant training, but obviously it only depends on the type of environment as well they are using the stretcher. Providing it's a medium risk or below, it can't be anything greater than that. There is additional training, bolt-on training called BA rescue, which would obviously assist in that type of activity using stretchers and extrication equipment from confined spaces.
Yeah, well, I think that's us now pretty much at the hour. As I say, there's a lot of questions and we will work through them afterwards. But for me, I just wish to thank David and Paul, attendance, thought it was a great presentation, a lot of information in there. Thank you.
Yeah.
Thank you very much.